Hi, folks. Thanks for coming. My name's Manish. I'm a product manager on Google Compute Engine. And today we're going to be talking about saving money on Compute Engine. Before we dive into the topic, there is a dory for this session. My amazing colleague Scott's going to be moderating it. So if any questions pop up while we're going through the talk, feel free to post those questions there, and we'll answer some of those questions as well as take some live questions at these remotes at the end of the session. So wasting money on cloud is a very real problem. Our friends at RightScale do an annual survey. Basically, every year they do this, and just like last year, they found that 35% of cloud spend is being lost. That's a very large number, and what's causing it is a host of different things, right? It may be that you're running instances or resources that you no longer need anymore, or you've over-provisioned resources, or you just haven't bought the right discounts for the things that you are running today. But regardless, 35% over the past 2 years straight is a pretty big number. And it's not because customers don't care. The majority of respondents in this survey cite cloud optimization, cloud cost as a top concern. Yet the number is still so big. And the reason for that is it's not easy, right? Like, cloud is a really dynamic place. Things are constantly changing. There's new features coming to Compute Engine every week or every month. And then your actual environment, you have resources coming and going at whatever churn rate. You have no idea at some times. So it can be really hard to keep up. So in today's talk, what we're going to focus on are what are some of the common patterns for waste in terms of cloud spend and what you can do about it. We'll tackle that in four sections. The first, we'll talk about how Google thinks about pricing products. The second is we'll talk about understanding what are the resources that you're actually paying for. If you don't understand what the resources you're paying for are, it's really hard to optimize those costs. And then we'll talk about those common areas where waste happens and what are tactical things you can do to sort of remove that waste. And then finally, we'll close on optimizing the types of discounts you can make or purchase to help optimize the actual resources that you're running. So let's get started. We'll talk about pricing principles first. So when we at Google Cloud think about pricing products, we try to keep 3 principles in mind: simple, flexible, and fair. Now, these principles can mean a lot of different things to different people, so let me talk through each one of these and describe what it means to us. Simple means powerful enough to meet your needs without being unnecessarily complex. And so that doesn't mean that a 5-year-old should be able to understand your cloud bill, but it also doesn't mean that you should be required to have a PhD in finance to figure out your cloud bill. And so one of the features that we launched last year is something called resource-based pricing. Resource-based pricing basically charges or meters usage against each resource as an independent SKU. So it's super easy to figure out where you're spending your money. So you could look at it and say, oh, I'm spending X dollars on cores, Y dollars on RAM, and some money on some premium OS licenses. So there's no weird bundles to sort of reverse engineer. There's no hidden costs. It makes things super simple and easy and transparent to figure out what's going on your bill. Flexible. So we get it. Things change over time. And you shouldn't be scared to make a decision today and be punished if things change in the future. So this is something that we spend a lot of time on with our pricing models. We think really hard about how do we make things flexible enough so that our pricing models can evolve and adapt to your evolving workloads and your changing workloads. One example of this is something that we call committed use discounts. And the idea with committed use discounts is you purchase an aggregate commitment for X amount of resources, say 1,000 cores in a specific region. And in exchange, you say, I'm going to pay for that for 1 or 3 years. And you can get some fairly deep discounts this way. But what makes committed use discounts flexible is that we're not asking you for a specific machine shape or a specific zone or a specific operating system or network type or anything like that. You're just telling us what region and the amount of cores. And now you can run whatever VMs you want. So VMs can come and go. You can change shapes. You can change zones within the region. You can change operating systems. Those commitments that you made on day 1 will continue to apply. So the whole goal here is so that you shouldn't have to feel afraid to make some of these commitments on our platform. And then finally, fair. Fair, first and foremost, means a low competitive price, always. what it also means, though, is that if we see that you're wasting money in some way, for example, if you're running an over-provisioned instance and we notice it, we're going to get in your face and we're going to tell you about it so that you can take action. We call that instance right-sizing. Another thing that we do, or what's sort of driven from our fairness ideal, is if you happen to do something with your workload and it saves Google money, it's only fair that we pass those savings on to you. So if you, for example, if you run a resource for an entire month, that gives efficiency to Google. And so Google should pass some of those savings on to you. And so we do exactly that with something called sustained use discounts. You don't need to tell us anything. You just run your workload. And if you happen to run it for some steady state within the month, you'll automatically get discounts. And this commitment to simplicity, flexibility, and fairness is not something that you find with all cloud providers, and definitely not something that you've seen from all cloud providers from day one. So let's move on to the second section, where we're going to start talking about understanding what are you actually getting charged for in terms of the resources that you run within Compute Engine. So at a high level, you can group the resources into two buckets: the base VM, which is the cores and RAM, and the attachable resources. So these are things like GPUs, persistent disk, licensing, and there's a whole bunch of other not little, but other resources like local SSD. So one of the things here is, one of the core things around Compute Engine is providing visibility into the resources that you're running. And so when you're trying to optimize your cost, you want to understand where you're spending your money. So a lot of Compute Engine customers most of their spend ends up on their base VM, the cores and RAM. But there are attachable resources that can be quite expensive, like a V100 GPU, for example. And so optimizing your GPU spend can also have a material impact on your overall bill. And so with resource-based pricing, which is something that we talked about a little bit earlier, it's really easy to get a picture of what you're actually spending your money on. And so you can kind of stack rank and focus, where do I need to spend the most attention initially, which could be your cores and RAM. Or if you're a heavy GPU user, you may be wanting to optimize your GPUs. So how do you figure out what's actually running right now? So if you want to understand what's happening at a point in time right now, you can take advantage of our instance list and describe APIs. So with the list API, you get a list of all of the instances that are currently running on your project. And then you can use the instance describe API to see what exactly that instance is. And so the cost-driving fields here are things like machine type, right? So this is the base VM, the core and RAM. There's also accelerator type and accelerator count. So these are the GPUs that are running and the number of GPUs and the type of GPU. There's your disk. And so there could be multiple disk objects within that resource in the API. So you could have persistent disks, multiple persistent disks attached to your VM, or you could have a local SSD disk as well. And local SSD can also be a fairly expensive resource. And then you can also take a look at what's running in terms of the licensing or the premium OSs attached to the VMs that you're running. So seeing what's running at sort of that moment in time is useful, but a lot of cloud environments, what's running right now is not indicative of what ran 4 months ago or over that period of time between 4 months ago and today. And so for that type of historical analysis, we have a really, really awesome tool. It's called BigQuery Billing Export. Once you enable this export, what basically happens is all the usage that is charged against your project and all the different SKUs will get logged and put into a BigQuery data set. And then you can do analysis on that data set for whatever time frame you want. The main thing that I would point out is that it's not sort of retroactive. So once you enable it, that is when the data will start getting stored. So if you're not going to get historical data if you haven't activated it yet. And so the idea here is really simple. It's a really simple example that's up here. You can ask the data set to give you all of the SKUs associated with Compute Engine for a specific project or for a billing account or multiple projects if you want. And then you group by the SKU name, and then sum up the cost, and then sort in descending order by the cost. And what that will give you in terms of an export is exactly all of the specific resources that you're paying, from the most expensive on your bill all the way to your least expensive. So in this example, it's a bunch of N1 standard cores, some N1 standard RAM, and then there's some V100 GPUs running. So this is a really, really powerful tool. So something I really encourage you folks to turn on when you start creating your projects, or if you already have a project, turn it on. It's a great way to sort of analyze what's happening and assess what you should do in terms of optimizing your cloud costs. So now I want to introduce a fictional company. I took some of the usage patterns from a real company and applied it here, but this is not a real company. It's Example Inc. They just ramped up on Compute Engine. They're spending about $1.4 million a year now. They've done no work to optimize their bills. So nothing. They just started creating instances. So there's probably a lot of low-hanging fruit here. And the purpose of this example company is to help illustrate some of what an optimization can do on the overall bill for a semi-real example. And just to make sure that we're all kind of aligned, so they're spending $1.4 million. They've got a whole bunch of cores. So they have 230 VMs running across different VM shapes. They've got some GPUs, just 8 V100s. They've got about 120 terabytes of PD SSD, and they're also running some Windows workloads. So let's take Example Inc. on the journey of doing some cost optimization. So the first thing we would say to Example Inc. is pick the right size for your workload, instance size for your workload. And Compute Engine offers a great deal of flexibility here with something that we call custom machine shapes. And a lot of other cloud providers, what they require you to do is choose between a fixed list of predefined machine shapes. And sometimes what that means is that you have to pick a machine that is bigger than what you need in terms of cores, RAM, or local SSD. And that's basically waste. With custom machine types, what you can do is pick the right amount of cores, the right amount of memory, and not have to overpay for the cores and RAM that you would have to do with a predefined machine type. So a couple of caveats with custom machine types. There are some restrictions. So if you want a custom machine type, you have to do it in increments of 2 vCPUs, so 2, 4, 6, 8, and then 0.25 gigabytes of memory. Even with those sort of caveats or restrictions, custom machine types are significantly more flexible than most predefined machine types that you see out there. So there's real cost savings here if you leverage custom machine types. So if you have VMs running right now, or you're going to be launching instances in the future, think about right-sizing them. You may be over-provisioning these VMs, and there's significant savings here for you potentially. So predefined machine types are generally, most predefined machine types are in shapes of what we call powers of 2. And so that's 2, 4, 8, 16, 32, 64. And the reason that is that it makes bin packing on the cloud provider side really, really easy. So it's great for the provider, but it's not great for you because you're forced to pay for resources that you don't actually need. So let's take an example. Let's say you need 20 cores. In the old powers of 2 world, what you'd be stuck with is a 32-core VM. And that means you're paying for 12 extra cores that you don't need. So that doesn't seem really fair from our pricing principle perspective, right? So take advantage of custom machine types. Take a look at what you can do to shrink down your VMs to the right size. So in order to do that actual step, there's a little code snippet here. The idea here is you stop the instance. So there is an outage. You would change the shape of the VM, and then you would start the instance back up, and it would reconnect all your PDs and all of that. So there is an outage, so you want to do it during your maintenance windows, or if it's not critical as a dev test, you can just do it whenever it makes sense. So figuring out if you are over-provisioning an instance is not necessarily a simple task, right? Workloads can change over time, so you'd have to have a lot of telemetry. You'd be trying to see what's happening to the VM and trying to figure out, should I right-size it or not? So following our principles around fairness, we watch instances. We see the utilization rates. And so if we notice a VM that's being underutilized or even overutilized, we're going to tell you. We're going to get in your face, and we're going to tell you about it. And so we call this right-sizing recommendations. This is available in GA today. You can just log into the Cloud Console, go to the Compute Engine instance page, and you'll see a list of recommendations there. And with a push of a button, you can either accept or decline the recommendation and go ahead and do it. Again, there's an outage here, so don't just start clicking things. But it's basically propagated here so you can see what's happening. So doing that is great, but it's still very manual, right? So you have to log into the Cloud Console and one by one click the instances and figure out what action you want to take. And so today, what I'm excited to announce is that we're going to be enabling programmatic access to these right-sizing recommendations. So we call it the right-sizing API. And the idea here is you can query the right-sizing API, get a list of recommendations, all programmatically, and then programmatically decide if you want to take the recommendation or not, and then apply the right sizing. And so that would be a stop, a resize, and then a restart. And then you can take that program that you've written and schedule it so it runs daily or hourly or whatever it might be to keep up with the churn of instances that are coming on the fly, so that you can stay ahead of all of the new instances that are getting created so you don't have to keep logging in every day and doing right sizing manually. So it's pretty cool. It's in alpha today, and it's coming to beta soon. So keep an eye out for it if you find this interesting. So going back to Example Inc., Example Inc. realized that they've been running 96 core VMs when they only really needed 72 core VMs. And they're shrinking the memory in the same proportion as well. And as a result of that change in right sizing, they're able to save about 5% on their total bill. But they're not done there yet, right? So they have a whole bunch of other resources. So now they're moving on, and now they're looking at some of the attached resources that attach to the base VM. So that second bucket of resources that we talked about. And so some of these resources can be very expensive. So GPUs, local SSD, these are examples of potentially very expensive resources where small amount of waste can accrue to a very large amount of cost on your bill. And again, the powers of two are striking here again, right? A lot of Compute Engine provides a great deal more flexibility with GPUs than you'll find with other providers. And so an example here is, let's say you have a use case where you need 64 cores of VMs. 64 core VM. In the power of two world, there's a fixed ratio. If you want 64 cores, you have to get 8 V100 GPUs. But let's say you only need 2. Well, you don't have that option in the predefined world or the powers of two world. With Compute Engine, you can go ahead and create that 64-core VM and attach a 2-core V100 GPU. And there's significant savings here, right? So just looking at the GPU alone, it's $20 per hour versus $5 an hour. And so Example Inc. took a look at this, and they realized that they could shrink their 8 V100s to 4 V100s. And as a result, they saved another around 5%. So with these two steps, they're now saving about 10% on their total spend right now. So they're also using persistent disk. And persistent disk is a cheaper resource for sure. And you can have a lot of persistent disk, and it doesn't add up to that much, especially when you're comparing it to local SSD or GPUs or even the base core and RAM. But a lot of VMs have a lot of disks, and a lot of cloud workloads have a lot of churn where instances are coming and going rapidly. And so one of the things that we've seen from some customers is you end up in a situation where instances get deleted, but persistent disks that were attached to that instance don't get deleted. And so you end up with a whole bunch of orphaned persistent disks floating around. And you can imagine if you don't pay attention to this for a long period of time, and you have a lot of churn, instances are coming and going, you could end up with thousands, hundreds of thousands of persistent disks, or you might just start hitting your quota limits to prevent you from going too high. So one tactical thing you can do here is when you're creating your disk or your instance or attaching the disk to an instance, you can set a flag to have it auto-delete. And so when the instance is deleted, the persistent disks that you've marked this flag on will also get deleted. So it's a great way to prevent this orphaning problem that could be happening. One caution on this is it's a very powerful tool, right? It's a very, very dangerous thing, like in the sense of if you delete the VM and you actually want the persistent disk, there's a bunch of warnings that will pop up in the console and in the G Cloud interface and all of that. But if you keep going to yes, 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 that disk is going to get deleted. And if you actually do need the data, that's a really bad situation. So use this flag cautiously, especially if you have different people creating instances and different people deleting instances. You may have the right hand, left hand issue happening. But this is one thing that we've seen customers leverage to kind of prevent excess waste in terms of PD. So another thing you can do is take advantage of snapshots. So snapshots are 85% cheaper than a running PD SSD for the same amount of storage. And so with a snapshot, what you can do is take a snapshot of your disk and then delete the snapshot. Or sorry, delete the persistent disk. And the use case there is you have some PDs just floating around that you don't need, but you want the data. You're not attached to any instance, so why not just take the snapshot, save the data, and then when you need the data, you can rehydrate that snapshot back into a disk and then attach it to a running instance. And then the final thing here on sort of, these are very tactical things, but the final thing here is PD supports two types of disks, PD SSD, which is SSD, and then PD standard. PD standard is significantly cheaper than PD SSD, and not all workloads need the performance characteristics of SSDs. So take a look at your workloads and identify where it makes sense to use SSD and where it doesn't make sense, and convert over to PD standard where possible. So we're going back to Example Inc. again. Example Inc. took a look at their 120 terabytes, and they realized that about 14 terabytes of the PD SSD that they've provisioned, which is basically because they had a whole bunch of scripts and everyone just launched their instances and they just got PD SSD. They realized that they could cut 14 terabytes and convert that to PD standard. So that results in like a 1 to 2% increase in savings now. So it's still smaller than the larger instances, but that's kind of the point, right? Like, you're going to want to spend your time on where you're spending the most money first to get the best bang for your buck, and then go down that list of sort of the most expensive resource all the way down to the least expensive resource. So now they're at 11%, which is not bad, right? I mean, we've been at this for maybe 20 minutes now. We've saved them 11% off of 1.5 million. Not bad. Another thing you can do is leverage preemptible resources. And so preemptible resources is it's basically our most discounted offering. It provides up to 80% off of normal on-demand prices, but it comes with some slightly different characteristics. The resources act and look just like a normal resource, so the performance will be the same, availability is the same. However, you can only keep the resource for 24 hours. And there's a slight chance that you may be preempted before the 24 hours. So you may be asking, whoa, like this, who would use this, right? If you have applications that can checkpoint and tolerate sort of VMs coming and going and restarting at a certain checkpoint, this is a great way to save a lot of money on some of your workloads. So some examples here are sort of batch workloads, rendering, things like that, use preemptible resources heavily. All right, so we're going to switch to something a little more niche-y now, and we're going to talk about licensing. There's two types of licenses I want to talk about today. The first is vCPU-based licenses. So you may have some software that you've purchased that the software provider says you can run it in the cloud, but you have to license it based on each vCPU that you're running. You also may have some workloads that are heavily memory-bound and not compute-bound. So databases are a great example of this, where you need a whole boatload of memory and not a lot of compute power. And so we have a feature called extended memory that's directly addressed at this type of use case. And the idea here is that extended memory allows you to create VMs with much higher memory to vCPU ratios than you can get with custom machine types or predefined machine types. So for example, you could have a VM with one vCPU and 500 gigabytes of RAM. And so if you were to take that use case with a vCPU license, you would be responsible to pay for one vCPU license, but your workload in your database would still have 500 gigabytes of memory to work with. One thing I would call out here is there is an extra cost for using extended memory. So you're going to want to do the math and say, what is the cost per vCPU that I add? What is the cost? And then what is the cost for enabling extended memory? And so do that math. And many customers that I've talked to for certain software licenses, extended memory makes just a whole lot of sense because the vCPU licenses dwarf the cost of the actual VM itself. Another type of license that I want to talk about, the second type of license I want to talk about is server-bound licenses. So these are licenses that require you to license the physical cores or physical sockets of a server. This is not something that you could do on Compute Engine before. You may have noticed in the keynote today, we announced support for bring your own license on sole tenant nodes. And so the idea here is we're now going to expose the physical characteristics of our sole tenant nodes. So you'll know that there's X sockets, Y physical cores, which means now if you have some of these server-bound licenses, you can bring them onto these sole tenant nodes. So Windows is a great example of this. Windows Server. Windows Server is a great example of this. So before this feature, if you wanted to run Windows on Compute Engine, you would have to buy a license from Compute Engine. And even though you may already have Windows Server licenses that you purchased through Microsoft or through one of their third-party authorized dealers, which is kind of wasteful, right? You're basically paying for 2 licenses, and you can only use one of them. It doesn't seem super fair. So what you can do now is you can take the licenses that you have on-prem or that you've bought, and you can bring them over to Compute Engine via this feature, sole tenant, BYOL. And so the example here is these Microsoft licenses can be quite expensive. So just on the server license alone, it's more than the instance cost itself. So you could save more than 55% on Compute Engine today if you just bring your own licenses for Windows Server. But you could imagine that this starts to get really, really cheaper if you think that you're running, say, SQL Server, Microsoft SQL Server on it as well. So if you remember, we talked about Example Inc. Example Inc. did have a small footprint of Windows licenses. So they had 192 Windows Core licenses that they were purchasing through Compute Engine. With this new BYOL feature, they basically spun up some sole tenant nodes. They launched their Windows VMs into the sole tenant nodes. And as a result, they stopped paying Google and Compute Engine for these Windows licenses and instead are able to reuse the licenses that they have today. And the savings here add up to another 3 to 4%. And so now we're up to about 15% total savings here. So we've gone through a whole bunch of different things in terms of being able to reduce your bill from a resource perspective. And so the whole point of this is to take all of the waste that's happening with the resources that you're running and bring it down to just exactly what you need. Right, and there'll be some noise there, but that's the whole point of that section 3 is to figure out how do you shrink this down so that what you're using and what you're being charged for is the minimum amount that you actually need. Once you do that, then it's time to start thinking about, okay, now I've got this minimum amount of usage. How do I optimize the discounts available to me? So the first one, we've talked a little bit about it, but it's super simple and easy. It's sustained use discounts, and the basic premise here is the more you run, the more you save. Up to 30% off if you run the resource for more than or for the entire month. And this is something that we've continued. This is something that we launched many years ago, and we've continued to invest in it to try and make it more flexible and more fair. And so today, what you can do now is you can start and stop VMs freely. You can change the shape of your VMs. So you can go from N1 standard 4 to N1 standard 16. The sustained use discount will continue to accrue on a core and RAM basis, independent of those two things. And you can change zones within a region. So this gives you a whole boatload of flexibility with sustained use discounts. So you can run these different instances. Things can change over time. And at the end of the month, we'll look at what you ran. And if you ran a resource across different zones in the same region and different VM types, but if that core ran for a full 30 days or 31 days, you'll get 30% off. And so we're going to do that calculation for you. And it's only fair, right? We're going to give you the optimal discount based on the usage that you're getting. So a little bit of complexity that I want to add here that has been recently added is we do split sustained use discount into 2 buckets today. So we have something called the general purpose bucket and the memory optimized bucket. And so general purpose VMs are the N1 standard, the N1 high mem, and the N1 high CPU, as well as custom machine types and sole tenant nodes. And memory optimized are memory optimized VMs. So these are N1 megamem and N1 ultramem. And so what I mean by separate buckets is that when I was saying that you could change VM shapes, if you were to change between a general purpose VM and a memory optimized VM, the sustained use discounts don't stack. These are two different pools or usage graphs that we look at to optimize in terms of cost. So I think an example might make this a little clearer. So here's an example. You're running an N1 standard 4 for half a month, and then there's some event, you get some whole bunch of new traffic pop in, and as a result, you increase the size of your VM to an N1 standard 16. So it's only fair you ran 4 cores for the entire month, right? So sustained use discounts will give you 30% discount on those 4 cores. And for the remaining 12 cores that are there, that got added as part of the N1 standard 16, that ran for half a month, so you'll get around 10% discount, which is the half the month type discount. So going along, so now if we have 2 separate sustained use buckets, let's say you started with an N1 standard 4, and then you converted to N1 megamem, whatever. So different bucket, sustained use buckets. In that scenario, you'd only get half a month sustained use discount for the N1 standard, and then half a month discount for the megamem. So you only get the 10% discount. You won't get that those 4 cores won't get the 30%. So something to be aware of. So there's some restrictions in terms of the different instances that you change to. There are some restrictions that are happening there. So sustained use discounts is pretty cool because you don't have to send any signal to Google and say, hey, I'm going to run this. And you still get up to a 30% discount if you happen to run for the entire month. But in some use cases, you may actually know that you have some steady state workloads that are going to run for 1 or 3 years or even longer. And in those scenarios, you should be able to get an even lower price or a bigger discount. And so for that, we have something called committed use discounts. And the idea with committed use discounts is in exchange for a 1 or 3 year commitment, you get a deeply discounted price. And so for 1 year, you'll get 37% off, and for 3 year, you get 55% off. And we've tried to make committed use discounts very similar to sustained use discounts in terms of flexibility and fairness. So with a committed use discount, you tell us in aggregate what you want. So you could say, I want 10,000 cores and 5,000 or 50,000 gigabytes of RAM. You don't have to tell us the machine shapes or specific zones or operating systems. And so as you start spinning up those VMs, if things have to change, those VMs shut down and come back, or you change instance types within the general purpose pool or the memory optimized pool, the discounts will just accrue. Another use case that we've seen is, and this is, I think is pretty neat, is that when you get to like really large scale, although any single user or project may have a lot of volatility, when you start to add a huge amount of projects and a huge amount of usage, these customers will start to notice that there are sort of these low watermarks that they can buy committed use discounts out. So they're not actually buying for a specific workload that they know is steady. They just know that in aggregate across all the noise within their organization, they're always going to have 50,000 cores running. And they may burst 10,000 or 100,000 cores at any point, but they know that they're never going to go below that. So it's an ideal thing to purchase. So committed use discounts is maybe one of the most popular pricing models we've seen in the last on Compute Engine for the last couple of years. And so today I'm really excited. It's something that I have been working on. I'm really excited to announce that we're expanding committed use discounts to additional resources. So we're going to support GPUs as well as local SSD. And so it works very similar to committed use discounts for cores and RAM. So you can do a 1 year or a 3 year, and you'll get the similar discounts: 37% for 1 year, 55% for a 3 year. And we're going to support all of the GPU types that we have today. So the K80, the P4, the P100. Excuse me, and the V100. And the T4 is something that we announced, I think, today. So that's coming very soon, and we'll be supporting that as well. So if you are running GPU workloads that have some sort of steady state workload, this is a great way to save some money. So if you know you're going to run it for 3 years or even 1 year, it makes sense to buy these. I'm also excited, this is something I also have been working on. I'm also excited to introduce a brand new billable resource that you have to worry about. they're called zonal reservations. And the idea here is they provide peace of mind that resources will be available for you when and where you want them. And so the idea here is you can say, I need to make sure that I always have 100 N1 standard 32s in US Central 1A. So that's a specific zone and a specific machine shape. You can create these reservations, and so long as we grant the reservation, you now know that those resources are there for you, and you can convert them into running instances whenever you want. And there's a bunch of different use cases here. Some of the use cases are, for example, let's say you want to do a patch, and so you're patching and you're doing a rolling patch and some instances get deleted. You want to make sure that you have enough resources to make sure that you can complete the operation and come back in a healthy state. So that's one of the things that's going on there. So one of the things that we tried to do really hard with reservations was, again, live by those 3 principles that we talked about: simplicity, flexibility, and fairness. And so these reservations are effectively just like running instances from Compute Engine's perspective. And so any of the resources any of the discounts you may have purchased already, like a committed use discount or even sustained use discounts, should just apply like it's a running instance. So if you purchase some committed use discounts, you can imagine that these reservations look and act just like an instance from a discounting perspective. So if you happen to say, I bought a CUD for this running instance and I now want to make it a reservation, you can do that and your discounts will still, the committed use discounts will still work. And so similarly on a sustained use discount perspective, we'll have reservations for general purpose VMs as well as memory optimized VMs. And so when you create those reservations, they'll feed into those 2 different sustained use buckets that we talked about. Another new feature that we're adding, and so this one's so I should actually go back. So these are coming to beta very soon. In the next couple weeks, you'll see this become available. And another feature that is currently in alpha today is what we call committed use discount analysis reports. And so these are first-class reports within the billing UI within Cloud Console. And they're meant to help you understand, if you've purchased some CUDs, it'll help you understand what the financial impact of those things are. So you can get a sense of, am I utilizing my CUD or am I underutilizing my CUD? Should I be buying more CUDs? That type of thing. So that takes me to the end of the session. So there's a few breakout sessions I want to call out. The main one that I think is super interesting that I think folks will resonate with folks in the room is CST 301. And so one of my colleagues will be talking about many of the sort of cost-saving things that we've talked about that we're doing in sort of a manual way and doing it in sort of an automated way. And so there's a whole bunch of cool demos and code snippets that are going to be available there. So I strongly encourage you, if you found this interesting, to check that out. It should be super cool. And then I'd like to just thank everyone for attending and thank the production team in the back as well. You guys are awesome. Thank you so much. And then one sort of bookkeeping item. There is a survey for all of the sessions. So if you take some time, please fill it out. Positive or negative feedback is more than welcome. I'd love to hear what everyone thought. So now let's open it up to questions. Yeah, does anyone want to come down? Or we can start with the Dory. Oh, I think we have someone, maybe not. I'm not going to, I'm calling you out, sorry. All right, let's start with the Dory then.
Cool. There was one question on the Dory that was answered later in the slides, but it's worth calling out just to reemphasize. The question is, for instance right sizing, what other ways can this be captured outside of the console? Can this be an event on PubSub or exposed via another API? And I think you answered that a little bit later in the talk, where it is the right sizing API is available now as an alpha API and will be launching to beta soon. So you'll be able to consume those programmatically via that API. Yeah,
exactly. It's going to be super cool. And if you're interested in the alpha, like just reach out. It's my last name at google.com. So just reach out and we can try and get you guys into the alpha.
Go ahead.
Hi. Most of our compute engines are SAP based, and their cost is huge.
Yeah.
Every time we're asking or we're looking at it, we're getting the answer that SAP only certified this. Is there? I saw the flexibility of nodes versus cores, memory versus cores, because most of our systems are non-production. Only the production has to be standardized and SAP certified. All the other ones, we can really manipulate it the way we want. Is that something we should look into, or is this something that SAP is show-stopping it, or what's...
So, Scott, you may know this better than me, but I think it really depends on the use case, right? So if you are doing sort of a test environment, you probably want the environment to be very similar to what you're actually going to be deploying to production. If you're doing some toy stuff, it seems reasonable that you could at least play with it. But again, you have to talk with, I think you have to make sure that SAP is okay with allowing you to do some of this stuff.
But for example, like, obviously the quality system has to be as production, but for a project sit testing, the data is the same size as production. However, the compute engine or the CPUs, the disk and all that extra cost that we see, that maybe we can minimize.
Yeah.
Is this something that everything that basically question, everything you said to the compute engine, does it apply to the SAP compute engines or the SAP templates that we use?
I think for the non-production use workloads, yeah, I believe that's the non-production use cases for the SAP software and deployment is all that stuff applies. I think the key with the SAP certification and then the trigger of the licensing is like the production workloads require a specific, machine shape, specific configuration of PD, SSD, et cetera, and a specific guest OS like, SLES for SAP, et cetera. That's what triggers like kind of the production, aspect of your SAP deployment, and that's where I think the specific machine shapes and all the config needs to be met before they support that as a production workload. And in supporting that as a production workload, then they also charge the production licensing costs.
Okay, thanks.
Yeah, go for it.
Yeah, so what's your vision for provisioning the instance type via API? You showed that we provision it via SKU, but our customers would be more interested to see those things like instance types via like APIs and on the right scale, because it's easier to see rather than using BigQuery. So because all the other cloud providers provide that APIs where you can see those instance type and you see the cloud spend or the instance.
Oh, I see. So
right now,
API access to the BigQuery export data.
Right, I think right now we do not see those things provisioned via like right scale as you see it for AWS or Azure. So that's missing. So how do you like provision to have
Sorry, I'm going to step away from that. Sorry.
how do you envision it to like provide those access to?
Yeah, I mean, I think the data we want to share, right? So fundamentally, like, this is just a sort of prioritization thing, right? So I think as we get more feedback of this type of thing, these are things that we can add. And so I can't specifically speak to what we're doing, but
that's a real frustration for our customers that it's not able to access via the third party or Google doesn't allow the API access.
So I think just so it's super clear to me, the ask is the ability to query
the instance type
from the API.
Third party, yeah.
Got it. Okay, so it's not actually. So it's not about the BigQuery export. It's about being able to look at what's running right now and call the APIs.
There's an option which you showed up in the beginning of the presentation.
Yeah.
Like, that you can use SKUs and then
instance.list and instance describe.
It's inconvenient rather than having a visualization and doing it via BigQuery.
Got it. Okay, this is good feedback. Thank you.
Yeah.
So there's another question from the Dory. Are you going to allow moving committed use discounts between projects?
So I can't announce anything specifically, but this is something that we hear constantly, and our roadmap is driven by customer asks. So just keep your ears out.
Any plans to include PDSSDs in CUD, like offer CUDs for PDSSD?
Yeah, I think so. This is something that I've been discussing with our internal team in terms of how we want to expand committed use discounts beyond just sort of compute engine in general. And so this is something that we are looking at. There's nothing immediate that's coming, but totally get it. I think some of the challenges on the PD side is that PD tends to be fairly cheap already, so I'm not sure if we're going to be able to offer, say, like a 55% off discount for a 3-year commitment on some PD. So there's some viability things that we need to look at there.
And the last one from the Dory, if there's no more in room, it's not quite a question, but maybe it's something that you can provide some insight into. You need to have an SA agreement with Microsoft to gain mobility. Also, there are restrictions on Microsoft applications that actually have mobility rights. OS is not one of them, and then they provide a link for more information. Like I'm not sure what that translates to.
Yeah. So it's super confusing. I get it. And so as part of the BYOL launch, the beta launch that went out today, actually, there's going to be documentation that talks about what's allowed, what's not allowed, and gives guidance. In the end, you do need to look at your EA with Microsoft and make sure that it is in compliance. But a lot of these EAs tend to be standard language. And so there will be material as part of the sole tenant BYOL documentation that talks about this in detail.